I've had a request to demonstrate how you calculate integrals on the TI-8384 series calculator. Before I actually do one, I'm going to talk my way through it. Somewhere on your calculator, there's a button labeled Math, so we'll print that. Within that menu, whether it shows up on the default screen or not, somewhere there is a thing called fnint. If you select that and press enter, the word fnint open parentheses shows up on the screen. Now, what you have to type after that is the function that you want to integrate, the name of the variable, the lower limit of integration, the upper limit of integration, all with commas separating the individual items. Then you have to type a close parentheses to go with the open parentheses that the calculator put on for you. And then you type enter, and then it goes off and it does probably some variation of Simpson's rule and quickly comes back and tells you what the value of the integral is. As a sanity check, we're going to do the approximate integral method using something that we know the exact answer to. So let's calculate the integral from 0 to 1 of x squared with respect to x. As everyone knows, an antiderivative is 1/3 x cubed. I must evaluate that at 1 and at 0, and then subtract. The result will be 1/3, which is 0 point an infinite number of 3's afterwards. So if we wanted this in decimal, we could write it that way, or if we wanted it in a slightly fancier notation, we put a bar over the 3 to indicate that that pattern endlessly repeats. Let's do this on the calculator. I'm using an older TI-8384 series calculator because it's easier to read. On this calculator, the math button is here. It's in the first column, third row down. So when I press math, I see a lot of different things. On this calculator, I don't see the fnint. That's because it's choice number 9, which was at the bottom of the screen below it a little bit. If I knew that ahead of time, I could have just typed 9. We'll show that in an example in a minute. But anyway, having got my cursor on the fnint, I press enter. It puts fnint open parentheses on the screen for me, and I can write in my function, x squared. The comma is directly above the 7 key. So comma, the name of the variable is x, comma, 0, comma, 1, and then I should have a close parentheses to close the open parentheses that came with the fnint. Having done that though, all I have to do is press enter, and it goes off and does its approximation scheme and comes back and gives me what is obviously the right answer. As another example, I'd like to look at the integral from 1 to 2 of sine x over x integrated with respect to x. Unlike what we had before, we don't know an antiderivative for sine x over x, so at the moment we have no reasonable way of doing this integral except by using the approximation method that we've described in the calculator. One thing that you do have to be careful about in mathematics in general, like in this integral, if I don't specifically say different, when I talk about trig functions of numbers, my calculator should be in radian mode. That's going to make a big difference, as we will see in a moment. So let me go into the mode setting. At the moment, I'm in degree mode, which is no good. So go down to radians and make sure that that's highlighted instead. I moved the cursor so that you could see what's going on. Second, quit. So I'm back out on this screen. So math, on this calculator, I happen to know the one I'm after is choice number 9. So I can just go ahead and do that. I'm going to calculate sine of x. Don't forget to close parentheses on the sign, divided by x, comma, name of the variable, which is x, comma, 1, comma, 2, close parentheses. And if I've done all my typing correctly, shortly it comes back and tells me that the integral is about 0.65932. Now, this business about the degrees and radians, we've got to be serious about that. What if I had made a mistake and had my calculator set in degree mode instead of radian mode? There's a trick I can do on the calculator. If I say second, enter, it brings up the last thing that I type. And in fact, if I keep doing second, enter, and so on, it lets me back up through all of the commands that I've issued recently. So I'm going to calculate that same integral again, just by pressing enter. And you see, I don't get anything near the right answer. And it's because we've got trig functions running around. And by default, you should think of, when you have integrals involving trig functions, that the trig functions are being evaluated in terms of radians and not degrees. And lastly, I want to do an integral that's similar to the one that sparked the question in the first place. I'd like to do the integral from 0 to 4 of the square root of 1 plus 9x squared with respect to x. By the time we finish the next chapter, we'll know how to do that antiderivative in closed form, but at the moment, we don't know how to do that. So we'll get the calculator back out again. Math, I know that it's choice number 9, so I'll just cut to the chase. Square root of, I've got my calculator set in classical mode, so it put the square root symbol and an open parentheses on. 1 plus 9 x raised to the 2 power. The closed parentheses that I just put on was the closed parentheses for the square root. Then I have to say comma, name of the variable, comma, the lower limit of integration, comma, the upper limit of integration, and then I have to do close parentheses for the fnint function. Then press enter, and after a while it comes back and tells me that the integral is about 24.61. The request was just to demonstrate how to do this on the calculator, so that's all I'm going to do about this. If you're interested in how it's doing these estimates so quickly and accurately, there's a course called Math 4670 Numerical Methods, in which we talk all about this sort of thing. But I'm going to stop there. I hope everyone has a good and productive day. I'll talk to you soon.